Lesson 91, Multiplicative Property of Inequality. Okay, so we know that when we have an equal sign, we're doing an equation. When we multiply both sides by the same number, it remains the same. So we can multiply by any number. Because it is an equal sign, there's a balance. So we could multiply by a -1 if we wanted to, right? And we would get -1 times 5, and then we would say -1 times 2, and a -1 times 3. Okay, we'd get -5 equals -2 minus 3. That's still a true statement because it is equal. They're equal on either side. So as long as you do the same thing on one side, you get the same answer on the other side. And that is going to always be true for an equation, which is just a statement with an equal sign and two sides to balance. However, when we talk about statements of inequality, that is not the case. If we have 8 is greater than 5, and we look at that and we evaluate that, these two are not the same. So we cannot do the same thing on both sides and expect them to balance out because they're unequal. They're not the same. So if we were to multiply times a positive, let's say if we multiply by a positive 2, we would get 16, okay, is greater than 10. That's true for a positive. But when we bring in a positive doesn't call for the opposite number, but a negative does call for the opposite number. So when we start talking opposite numbers, if we were to multiply both of these by a -1 and turn them into negative values, -8 is not greater than -5. So that statement becomes false. So what we have learned in dealing with numbers is that when we multiply an inequality statement, we will do both sides, but we have to flip our inequality sign. We have to get the opposite inequality sign to keep the statement true. So whenever you see a negative number or a negative variable and you want to get rid of that negative variable so that the statement is more understandable, you're going to flip the sign when you multiply both sides by -1. For instance, if we have negative x is less than a positive 2, we are going to multiply both sides by -1 because we don't like negative x. Negative x does not make sense. We want our variables to be positive, okay? We don't want to have to think about, okay, what's the variable and what's the opposite of the variable. We just want to know what the variable is. So we're going to, when we multiply this times -1 and this times -1, we're going to flip this statement. So then this becomes x is greater than -2. You see how that works? We multiplied both of these by a -1, and when we did, we flipped our inequality sign and it kept the statement true. So that is what you have to do when you multiply by a negative number. So let's try that out. Let's clear the page. 91.1. We have a solution which is -x is greater than or equal to 2, and the domain is real numbers. Okay? In order to make sense of this, -x does not make sense. We can't graph -x. We can graph x, but not -x. Because what we'd have to do is we have to graph it and then flip it and get the opposite. And that doesn't work on a number line very well. So we're going to multiply this times a -1, which will give us -1 times -x is a positive x. We're going to flip the middle sign, and then we're going to -1 times 2 is -2. This remains the same. Okay? So now we can actually graph that. We can create our number line, if we can actually draw a straight line there, and we can graph that. We can say, okay, if this is, give me some little lines here, 0, -1, -2, -3, -4, and this is 1, 2, 3, 4, 5, 6. We can say that x is less than or equal to -2, and it goes that way. Okay, so we can graph that. Graphing this, not so much. It's harder to do. So we would have to say what this literally means is, we know that -1 means the opposite. So what we're saying is, when we read this, I want the opposite of x is greater than or equal to +2. And the opposite of that is that x is less than or equal to -2. Right? Do we see that? Okay. So let's move on to 91.2. Let's clear this. 91.2 states, or asks, I should say, to graph the solution for -x is less than or equal to 6. Ooh, that's a hardie. So what we have to do first is we have to get x by itself. So we subtract 4 from both sides. That gives us -x is less than or equal to 2. Again, we don't like a -x, so we're going to multiply and flip. So -1 times -x is x is greater than or equal to -2. And then we can graph that. And the domain for this was integers. So how do we graph integers? We graph integers like this. If we have, this is 0, 1, 2, 3, 4, 5. And this is -1, -2, -3. This is as far as we need to go. All right, so if x is greater than or equal to -2, then it's equal to -2. So we can graph 2. We can graph -1. We can graph 0. We can graph 1. We can graph 2, 3, 4, 5. And then we want to graph this little arrow down here. Just fill it in so we know we're going this direction. So that's how we would graph integers. We do not mark the lines in between. We only dot the integers. Okay? So x is greater than, means it going to the right, or equal to, so we fill in the dot on the 2. Okay, on the -2. And that's how we'd graph that response. Let's go on to 91.3. 91.3 says to graph the solution -3x plus 4 is less than or equal to 13, and the domain is all the real numbers. All right. So first, let's add 4 to both sides, or add -4 to both sides. So it gives us -3x. This cancels, and this says it's less than or equal to 9. Okay, we're going to divide both sides by -3. Now, because we're dividing by -3, it's just like what we did before. If we divide or multiply by a negative, we have to flip the sign. So x is going to be greater than or equal to negative 3, because a positive divided by negative is a negative. And it's going to be all of the numbers in the real number set. So our graph is going to look like this. We're going to have 1, 2, 3, 4, 5, negative 1, negative 2, negative 3, negative 4, negative 5. So we're going to come over here to negative 3, and this is 0. And we are going to, because it's equal to, we're going to fill in the circle on negative 3, and x is also greater than negative 3, so we will go to the right so that the numbers will get bigger. Okay, I'll do that in green over the top. You'll see it a little bit better. There you go. So that would be how you would graph that. All right, let us move on. Let's see if there's another one. Nope, that's all for the statements of inequalities. Just remember, when we multiply or divide by a negative, actually, I should say when we multiply or divide an inequality by a negative, we flip, or actually flip is not the right word, reverse is the right word. We reverse the inequality sign. And you're going to want to make a note of that. That's something to remember, because that's going to always be the case. All right, so take down this note, and I'm going to clear the page, and we're going to go to spheres. We're going to learn how to do volume and surface area of spheres. So I'm clearing the page. All right, 91B, spheres. A sphere is a perfectly round, three-dimensional shape. All points on the surface of a sphere are the same distance from the center. Think about a ball, okay? Think about a drop of water if it were suspended in zero gravity. The volume of a sphere is equal to 4/3 times pi, okay, times r cubed. You could also say 4 times pi r cubed divided by 3. That's the same thing. Okay? And the surface area, this is the volume of a sphere. The surface area of a sphere is equal to 4 times pi times r squared. Okay, remember that a circle is 2 pi r. Well, this is 4 pi r squared. So think about that for just a second, because we have this extrusion going on. We are not just talking about a flat surface anymore. We're talking about something that has extended up and down and forwards and back and left and right. So it has expounded. So just remember, or go ahead and write down these. These are your formulas for the volume of a sphere and the surface area of a sphere. Okay, and we're going to do some practice problems. So let's do 91.4. And we're going to find the volume of a sphere whose radius is 3 centimeters. And we want the volume. Okay, so we just use our formula over here. And the formula is 4 times pi times r cubed divided by 3. That's the one I like to use. It's the same thing as this one, just written a little different. So we have 4 times pi times 3 cubed divided by 3. Right? So we are going to say 3 times 3, that's 9, times 3 again, that's 27 over 3. So now we're going to figure out 4 times 27. Let me turn on my calculator here. 4 times 27, that's 108 pi divided by 3. 108 divided by 3 equals 36 pi. And that's going to be meters cubed because it's volume. Okay? That is the answer I'm going to look for. Now, if you were to multiply 36 times pi, then I'm going to go ahead and box it in so it's clear. You could also do 36 times pi, which is 36 times 3.14, and you would end up with 113.04 meters cubed. Same answer. I'll take either one. I'm not picky when it comes to that. You can stop here. There's no reason to go ahead and multiply because this is an acceptable answer to me. Okay? But if you just want to do that extra step, you can do it. Just know there's no extra points. It's the same thing. All right, now we're going to do the surface area. Okay, so we're going to do 91.5. I'm going to erase this. So if you need to take notes, pause it. 91.5. We're going to do the surface area of a sphere. And in this case, the radius equals 4 meters. Right? So the surface area formula is 4 pi r squared. So that equals 4 pi times 4 meters times 4 meters. Right? So 4 times 4 pi times 16 meters square, right? So 4 times 16 is going to be 32 plus 32. This is going to be 64 pi meters square. And that would be the answer I would accept if you wanted to go ahead and multiply times 3.14, which is pi. That would be 200.96 meters square. I'll take either answer. Again, as far as I'm concerned, they're the same answer. But as far as mathematicians are concerned, this is actually the more exact answer because pi is an irrational number. And you rounding it to 3.14 is, while it's convenient, it's not exact because pi goes on forever. So this is a more correct answer than this is for most mathematicians. Just giving you a heads up. If your teacher, when you get to Algebra 2, or you get to college algebra, wherever you might be going, asks for the exact answer, this is the one they're expecting because pi is the exact answer. That is all we have for lesson 91. Short lesson. So again, if you have any questions, write them down, bring them to class, or submit them to me beforehand if you really need the answer quickly. Or sooner, I should say, because I don't know that I'm quick at all. And that's all I have. I will see you in lesson 92.